My name is Heather Pfeiffer, and I look forward to speaking with you today about paradigms of machine learning. Um, there are other types of machine learning paradigms that will do not reach the scope of this. This is just a high-level overview. But if you look on the right-hand side and you have some experience with machine learning, you might have identified that here at the top is a representation of supervised machine learning, and this B graphic is unsupervised machine learning. So we will look at these two over here, specifically two types, which is regression and classification for supervised, and for unsupervised, we'll take a look and give some examples for clustering. All right, so supervised machine learning. What is it? In essence, it's training with labeled data. Another way to say this is the model is given the correct answer via a label, and then it learns to map out the inputs to those labels in order for it to reach the goal, which is an accurate prediction of outcomes. Different types that are included in here are regression and classification. Classification also has two types on its own, binary and multi-class classification. For regression, we're looking at numerical data, specifically continuous data. So that might be looking at bike sales during certain seasons. For classification, we're looking at more Boolean-like values. So we're looking for a yes or no, a true or false value. And let's take a look at an example here. So for example, you have labeled data that is spam or not spam. And when we have email content, the model is trying to identify whether or not that mail is spam. For unsupervised, it is the opposite. So we are training with unlabeled data, not coming in with any correct answers. And really, what the model is having to do is explore the data to find those relationships between the data. And many times, what does happen is we find hidden patterns or structures within the data. Unsupervised learning can sometimes be a precursor to supervised learning. So, using techniques down here at the bottom, like clustering, might be a precursor to one of those supervised learning models. The goal of unsupervised learning is to, as I mentioned, identify those patterns and structures without having any predefined outcomes given to the model. Beyond clustering, another type is anomaly detection. If we look at an example here, we can think of a market segmentation. We're looking for our market segment using what is known as k-means. So we'll use a k-means algorithm. And here we might have customer features like age or income that is then vectorized into n-dimensional coordinates. The algorithm groups customers into what is called k-clusters. And if we look here in the middle, we have these centroids. So basically what the model is doing, it's assigning it to the nearest centroid. And those centroids will continually move a little bit because as we're iterating through the data, the clusters will start to stabilize and reveal distinct customer segments. All right. In conclusion, supervised and unsupervised learning plays a crucial role in machine learning. Both of the paradigms help us to uncover valuable insights from the data. And really, the keys to success is choosing that right paradigm that suits your needs and ensuring the data that's coming in is of good quality. We have clean data that is coming into our models to get the best results. Here are some of my sources. And it was it was a pleasure speaking with you today. If you would like to discuss this with me further, or if you have any questions or just want to connect, my LinkedIn is here at the bottom. So feel free to do that and have a great day.